In this video, we're going to start modeling roof trusses for a residential timber house. First, I'll walk you through the traditional method, the one you'll find in pretty much every tutorial out there. And don't get me wrong, it works, but it takes way more time than it should. So if you already know this workflow and just want a faster, cleaner way to do it, feel free to jump straight into the next video. But if you want to practice the normal way anyways, stay with me. Shall we?
Okay, now I'll finally start modeling the roof and all the trusses that go with it. And to start, let me show you something that not many people know about trusses in Revit. It actually comes with two different types. So I'll start with the one that everyone usually knows. All right, for that, I'll close this window and jump into the level 1 plan. Actually, for now, I'll also close the 3D view and just leave these two windows open. Now I go to the View tab and hit Tile Views, so I can see both views at the same time. I'll just center them a bit, and on the left side, I'll bring back the 3D view. While I'm here, I'm going to tweak a few visibility settings. I'll search for the roof category and give it a bit of transparency. Maybe around 25. Let's see. That's a bit too much. I'll drop it down to about 10%. That's enough to see what's going on underneath. Now I'll also change the surface color. Maybe something like this blue. Yeah, that looks pretty good to me. You can also tweak how materials look using this option down here. All right, that looks good. Now I'll go back to the plan view and shift this partition a bit to the right so we've got some space to start modeling the trusses. To do that, I'll head over to the Insert tab and select Load Autodesk Families. This time I'll go into Structural Trusses and pick this one with 6 panels. Hit Download and just wait a second. That gives us the truss layout, but we still need the actual structural members, so I'll go back again to Load Autodesk Families, this time into Structural Framing, and I'll filter it to Wood members to find them quicker. You can pick whatever is common in your country, but for this example, I'll just grab the first one. Revit will show this catalog, so I'll pick this 64 by 114 timber beam. All right, now to actually place the truss, I go to the Structure tab and select Trusses. It works pretty much like beams. Just click on one side, then go to the other side and click again. You can see this line showing where the truss will sit. Now I'll jump into the section view and adjust the view range so we can actually see it. And there we go. Now the truss shows up on the right side. Having these views stacked vertically isn't helping much, so I'll just drag this one out and dock it at the top so both views sit horizontally. That's better. We can see the full truss now. And as you've probably noticed, right now we're only seeing lines. That's because the detail level is set to coarse. I'll switch it to medium, and now we can see the actual geometry. All right, first thing we need to do is assign the framing types. So I'll select the truss and hit Edit Type. Here you'll see it's divided into top, bottom, vertical, and diagonal members. For each one, find the structural framing type, and from the list, select the timber beam we just downloaded, the 64 by 114. Hit OK, and now if we look at the section, you'll notice the bottom chord is sitting in the middle of the wall. We don't want that. We want it resting on top of the wall. So I'll select the truss again and go to the Properties palette to find Bearing Vertical Justification. From the drop-down, I'll switch it to Bottom. And there we go. Now the truss is sitting exactly where it should. And here is where we hit the first problem with these trusses. If I try to pull this so it sits fully on the wall, it just doesn't behave like normal structural framing. Even if I right-click the connection point, the disallow joint option is not there. So what you end up doing is stretching the line, trying not to break it, and kind of forcing it into position. I know, pretty frustrating. And that's not even the worst part. For now, I'll undo everything and go back to the original state. Now, to match the roof slope, you might think there's a simple parameter for that, but there isn't. So what we have to do is measure the roof height, let's say from the base up to the inner top of the roof. In this case, that's about 2,160 millimeters. Then I select the truss find the truss height parameter and plug that value in. And yeah, as you can see, that's not giving us the right slope. We actually need 17.5 degrees. So now you're stuck trying to find the right combination between height and span. And honestly, that takes way more effort than it's worth. So this method, yeah, not great. But watch this. There's another way that looks promising at first. I'll go to the 3D view, select the truss, then up here choose attach top or bottom. Make sure it's set to top, and then just pick the roof. You'll get this warning telling you some constraints are gone. And if we check the section, the bottom chord is no longer sitting on the wall. But now the top chord is perfectly attached to the underside of the roof. So if I extend the truss to the roof edge, now we finally get the correct slope. We just need to repeat the same on the other side. Now, here's the catch. Even though the truss says it's justified to the bottom, it's not really behaving that way anymore. So to fix it, I'd need to move the roof up, which then means adjusting the truss again. And you can see where this is going. It gets messy really fast. And even if you somehow get everything aligned perfectly, we still have another issue. Look at the connections. The members are not properly joining with each other. So now we have to fix that manually. First, select one of these members, right-click, and choose Select All Instances. Wait for the option to display and select Visible in View. Hold Shift and deselect the top and bottom chords, so I'm left only with the verticals and diagonals. Next step, I'll unpin them so we can actually modify them. Once they're unpinned, I can adjust the Start and End Join Cutback. I'll set both to -150. Actually, that's not enough for this one, so I'll push it to -300. There we go. Now I go to the Modify tab and select the Notch tool. Since we're cutting multiple members, I'll activate this option here. I start by selecting the element to cut, then the reference, in this case, the bottom chord. You can see the bottom chord stays highlighted, which means now I can keep cutting multiple members against it. Then I repeat the process for the top chord, and again for the other side. Now, one last thing. By default, Revit leaves a 20mm gap in the notch. So I'll select all these members again. Select one. Right-click, select all instances, and then Visible in View. Then Shift-click to remove what you don't need. Now, with only the diagonals and verticals selected, I go to Properties and set the notch distance to 0. And there we go. The gap is gone. Finally, we need to go through the truss and find all those parts that still need manual adjustment. And as you can see, there are quite a few things that still don't look right if we want this to behave like a real truss. So honestly, if you ask me, I would never recommend this approach for timber or wooden truss roofs. So now, let me show you the second method. This is the one most people don't even know exists. I'm not going to delete this truss just yet. I'll just move it far away from the model, somewhere around here just to keep it out of the way. Now here's the trick. Revit actually has another type of truss family. You won't find it in the default templates, but you can download it from Autodesk just like we did before. Let me quickly open a new project so I can show you. Go to the Insert tab, then load Autodesk Family again. But this time, instead of going into trusses, go back to All Results. Select Structural Framing and filter it to Truss Members. Here you'll find 3 basic truss types. I'll pick the King Post Truss and load it into this empty file. Now I'm in a plan view, so instead of using the Truss tool, I go to the Structure tab and select Beam. Remember, this is not a truss category family. From the list, I select the truss we just loaded and place it anywhere. Then I create a section view to see it properly. And this is what it looks like. And this is where it gets interesting. As you can see, this family already has all the connections solved. Everything is properly cut and notched. No manual fixing needed. All you have to do is select it, go to Edit Type, and start adjusting the parameters. And here are the 2 key ones. The pitch, which controls the slope, and the overhang distances, which, as you saw before, are a nightmare to control with the other method. Now, the reason I didn't load this into our main project is simple. This is not exactly the type of truss we need, and like we saw earlier, Revit only gives you 3 options here, and none of them really fit a typical residential timber setup. So if you want to use this approach, you would normally have to create your own families. You can open one of these, hit Edit Family, and study how it's built so you can create your own versions. But here's the good part. I already did that for you. I've created a full set of trusses that are commonly used in timber residential construction. We've got standard trusses, truncated girders, hip trusses, jack trusses, creeper trusses, valley trusses, and even a fully modelled gable end truss. Some of them also come with their mono truss versions, so check out the next video to see how you can get access to all of these.